Hello friends, I am Pooja Sangwan. Today I will discuss the logic gates, and in the logic gate we discuss the AND gate, OR gate, NOT gate, NOR gate and the NAND gate. First of all, we define the logic gates. Logic gates, it is a device that acts as a building block for digital circuit. It means we can say that in the logical gate we have 2 or 3 input and we have only one output. It means we can say that logic gates are used in the electronic circuit, and in the electronic circuit it gives the input, it gives the output when we apply the input. It means we can say that logic gates allow the data transfer. Now the type of the logic gates. Logic gates are of so many types. First of all, we define the AND gate. AND gate are those gates which have 2 or more input but only one output. Is this A and B? This is the input and this is the first input and this is the second input, and this line gives the output. It means we can say that when we apply 2 or more input, then it gives the one output. This is called the AND gate. In the AND gate, this is the truth table. Here this is the input and this is the output. A and B is the input and Q output is denoted by Q. So the Q is the output. When we apply 0 and 0, when we apply input 0 and 0, it means it gives the output 0. When we apply input 0 and input 1, when we apply input 0 and input 1, it gives the output 1. It means we can say that the input is first input is 0 and the second input is 0. It means it gives the output 0, because Boolean expression of the AND gate gives the Q is equal to A dot B. A dot B means A multiply B. A multiply B. When A dot B 0 multiply 0, 0. So we can say that this is the output. Now 0 multiply 1. When the input first input is 0 and second input is 1, then it gives the output 0, because 0 multiply 1 is equal to 0. Now in the next, when we apply input 1 and second input apply 0, then it gives the output 0. And when we apply input 1 and we second input apply 1, it means we can say that 1 multiply 1 is equal to 1. It means it gives the output 1. So we can say that in the AND gate, when both input are switch on, it means we can say that this input and this input, both input are 1, then it gives the output 1. If any one input is 0, then output is 0. It means it gives the Boolean expression, and Boolean expression is equal to A dot B. So this is the AND gate. When we have 3 input, it means we can say that when we have 3 input, in the same way the output is Q. Here Q is equal to A dot B. A dot B means A multiply B. When we input apply 0, 0, 0, then the output is 0. When we apply 1, 0, 0, it means we can say that 1 multiply 0 is equal to 0. So we can say that the output is 0. In the similar, both input are 0, but in the last case, when all input are 1, then 1 multiply 1 is equal to 1. It means we can say that when all input apply 1, then it gives the 1, and when any one input apply is 0, then the output is 0. It means we can say that in the AND gate, if both input apply 1, then it gives the output 1, and if any one input apply 0, then the output is 0. This is the AND gate. Now we discuss the OR gate. The OR gate symbol is, this is the OR gate symbol, A and B. A is the first input and B is the second input. Q is the output. Here Q output is equal to A plus B. A plus B means it is the Boolean expression. It means OR gate, the Boolean expression of the OR gate is A plus B. So we can say that this is the symbol of the Boolean, this is the symbol of the OR gate. When we apply input 0 and 0, when we apply input 0, first input 0 and second input is 0, it means it gives the output 0. It means Q, here Q is equal to A plus B, because it is the Boolean expression. A plus B. 0 plus 0 is equal to 0. Then the output is 0. 0 plus 1 is equal to 1. Because 0 plus 1 is equal to 1. So the output is 1. When 1 plus 0, it means 1 plus 0 is equal to 1. It means the output is 1. And when 1 plus 1, it means 1 plus 1. This is the switch on and this is also switch on. When both switch are on, at this case the output is switch on. Matlab it means 1. So we can say that in the OR gate, when any input is 0, then the output is 1. When both input are 1, then the output is 1. When both the input is 0, then the output is 0. It means we can say that input A and input B both are switch off. It means it gives 0 output. When any one input is 1 and any next input is 0, then at this case it gives the output 1. So we can say that OR gate are the different from the AND gate, and OR gate gives the relation Boolean expression A plus B. It means A plus B. In this case 3 input are the 1. Now we define the NOT gate. In the NOT gate we have only one input and we have only one output. It means we can say that we do not need two input. It means we can say that in the NOT gate we have only one input. When we apply one input, it means it gives the output once. It means we can say that when we apply any input, then it gives the output 1. A is the input and Q is the output. Here Q is equal to A bars. This is the Boolean expression. Boolean expression is Q is equal to A bar. A bar means if A is 0, then A bar is equal to 1. A bar means it is the negative. Input, when we apply input 0, then the output is 1. When we apply input 1, then the output is 0. It means we can say that this is the input 0. When we apply in 0 input, it means it gives the output. It means A bar is equal to 0 bar. 0 bar is equal to 1. When the input is 1, it means 1 bar is equal to 0. So we can say that the output is 0. It means we can say that it is the reverse of the input. When we apply 0, it means it gives the 1. When we apply 1, it gives the output 0. This is the reverse of the input. Now we define the NAND gate. NAND gate means NAND gate is the combination of the AND gate and the NOT gate. NAND means N-A-N-D. NAND gate means NOT plus AND. AND gate plus NOT gate. It means we can say that this is the AND gate and this symbol is the NOT gate. It means we also write this. This is the AND gate and this is the NOT gate. A input, B input, it gives the output A dot B. But in the NOT gate, it gives the reverse result. So A dot B bar, this is the output. It means we can say that when we apply input A and input B, it gives the output A dot B. But in the NOT gate gives the result reverse of the input. So A dot B gives the result A dot B bar. This is the output. So in the short form we write this. This is the AND gate and this is the symbol. This is the symbol of the NOT gate. Here A and B are the input. When we apply input, then it gives the output. This is the truth table. When we apply input 0 and output 0, it means input and output, both input are 0. Then A dot B is equal to 0 multiply 0. 0 multiply 0 is equal to 0. And the A dot B bar, this is the bar of 0 is equal to bar of 0 is equal to 1. So we can say that when both input are 0, then in this case the output is 1. This is the case of the NAND gate. In the similar way, 0 and 1, when we apply any input 0 and the next input is 1, then A dot B is equal to 0 multiply 0, 0 multiply 1 is equal to 0, and when the bar of 0 is 1. So in the similar way, 1, when we apply input 1 and the next input is apply 0, it means it gives the relation when 1 multiply 0 is equal to 0, when 1 multiply 0, the bar of the 0 is equal to 1, so it gives the relation 1. Now in the next case, input, when we apply input 1 and the next input apply 1, then A dot B is equal to 1, A dot B is equal to 1, the bar of the 1 is equal to 0, so we can say that Q is equal to 0. So in the NAND gate, we can say that NAND gate is the combination of the NOT gate and the AND gate, and the output of the NAND gate is equal to 0 when both input are 1, and when both input are 0, then in this case the output is 1, and when any one input is 1, then in this case the output is 1. This is the Boolean expression formula is Q is equal to A dot B bar. Now the next formula is NOR gate. NOR gate are those gate which is the combination of the NOT gate and OR gate. It means we can say that NOR gate are the combination of the NOT plus OR gate. It means this is the NOT gate and this is the OR gate. It is the combination of the NOT gate and the OR gate. So we can say that in the OR gate, we know that this is the symbol of the OR gate and this is the symbol of the NOT gate. So we can say that it is the combination. This is the OR gate and this is the NOT gate. Here we have two input A and B. The output of A and B in the OR gate is A plus B, and we know that in the case of a NOT gate, it gives the reverse of the input. So the result of the NOT gate is A plus B bar. It means we can say that when we apply 0 input and when we apply 0 output, then in this case 0 plus 0 is equal to 0, and the output of 0 bar is equal to 1. So we can say that in the truth table, when both input are 0, it means A plus B is equal to 0 plus 0 is equal to 0. Here input is, this is the reverse, Q is equal to A plus B bar. So we can say that 0 plus 0 is, this is the output of the NOR gate. Now in the next case, when we apply one input and this is the apply 0 input, it means it gives A plus B. So 1 plus 0 is equal to 1, and this is the NOT gate, and NOT gate gives the reverse of the input. Reverse of 1 is equal to 0. So we can say that the result of the NOR gate, in this case 0 and 1, that is 0. So we can say that when we apply 0 and second input apply 1, then in this case the output is 1. In the same way, when we apply here 0 and when we apply 1, then in this case 0 plus 1 is equal to 1, and this is not gate gives the reverse. So the bar of the 1 is equal to 0. So we can say that when we apply input 1 and we next apply input 0, then in this case 1 plus 0 is equal to 1, and the output of 1 is equal to 0. Now in the next case, when we apply input 1 and when we apply input second input is 1, then A plus B is equal to 1, and the bar of the A plus B, it means we can say that when we apply input 1 and the next input apply 1, this is the A plus B, A plus 1 plus 1. 1 plus 1 is equal to 1 in the OR gate. So we can say that the bar not gate gives the reverse of the input. So we can say that bar of 1 is equal to 0. So we can say that in the OR gate, when both input are 1, then it gives the result output 0. It means we can say that when both input is 0, then it gives the output 1, and both the input is 1, then it gives the output 0. So we can say that in the NAND gate is the combination of the NOT gate and the AND gate, and similar way in the NOR gate is the combination of the OR gate and the NOR gate. So we can say that AND gate, OR gate and NOT gate are the fundamental gate. Fundamental basic gate, it means it gives the relation between input and output, and it does not combine other gates. So we can say that this is the single gate. But in the NAND gate gives the combination of the AND and NOT gate. So we can say that this is not a fundamental gate, and this is also NOR gate is also the combination of the NOT gate and OR gate. So we can say that this NOR gate is not the fundamental gate. It is not a basic gate. It gives the result between the NOT gate and the OR gate. So we can say that first of all, OR gate, NOT gate and the AND gate are the fundamental gate, and NOR gate and the NAND gate are not the fundamental gate. These gates are the combination of the other gates. Now today here we discuss all logic gates and type of the logic gates. Thank you.